Okay guys, check it out. This bottom part of your notes is the most important part of this entire section. Do you have to know how to graph or how to solve with substitution? The answer is no. If you learn this method, elimination method, you're good. You don't have to use the substitution method. Anyhow, let's take a look at this example. The elimination method, it's also known as linear combinations method. So what we're going to end up doing is taking the line on top and the line on the bottom and combining them. We're going to put them together. All right, we're going to mash them together. Now, that's why it's called linear combinations. We're going to combine the lines, but your goal is to get something to cancel, right? You want to get either the x's to cancel or the y's to cancel, right? So if you look at step 1 right here, it says multiply one or both equations to get a variable to cancel. Now, let me just ask you this. If I look at this top equation and this bottom equation, and if I were to combine them, what's 4x plus x?
4x squared.
No, I just said plus, not times. It's 5x. In other words, 4x plus x, if I combine the 4x and the x, it does not cancel out, right? If I combine the 3y and the 5y, it does not cancel out. It gives me 8y. Got that, Sarah? Yeah? Okay. So I need to modify either one equation or both equations to get a variable to cancel either x's or y's. So step 1 says multiply one or both equations to get a variable to cancel. So you need to make a choice. Do you guys want to cancel out x's or cancel out y's?
Y.
X's. Now, sometimes it's great to cancel out y's. Sometimes it's great to cancel out x's. A lot of you guys just said right now you wanted to cancel out y's. Let's think about that. If I wanted to cancel out y's, this is a positive 3y. I would need this to be a negative 3y, and I can't change a 5 to a negative 3y. Or if this were a 6, then it would be easy because I could multiply the top one by negative 2 to make it a negative 6, which would cancel with a positive 6. Does that make sense? Now, if you did want to cancel out y's, which you could if you wanted to, you would just have to change this to a positive 15y and this to a negative 15y. But that would require you to modify both equations. Does that make sense? Now, if I say, oh, x's, that's pretty easy to cancel. All I need to do is make this guy look like a what? Like a negative 4. So how am I going to do that? I'm going to multiply the entire bottom equation by negative 4. And that's what I want you guys to do. You got to look at it. You got to think, okay, what's going to be easier to cancel, the x's or the y's? You know the x's are going to be easier to cancel. It requires less steps. So let's put a negative 4 out there in front. And this is just for my information. So if I ever need to look back to see what work I was doing, I know that this bottom equation got changed by multiplying by negative 4. So negative 4 times x is negative 4x. Negative 4 times positive 5y is negative 20y. And negative 4 times negative 9 is positive 36. Yay? Okay. If we take a look at the top equation, it's already set up because I'm not going to do anything to it because the first term is already a 4x. You already have a plus 3y right there equals negative 2. So ladies and gentlemen, that was step 1, to think about which variable you want to cancel and modify one equation or sometimes both equations to get that variable to cancel. Step 2, combine the lines. That's where the words linear combinations come from, or elimination method, because you're going to combine the lines to get those x's to eliminate. So check it out. We combine the lines, 4x, take away 4x, disappear. It's gone. All right? What about the negative 20y and the positive 3y? Negative 17y. And how about the negative 2 and the positive 36? That's 34. And what about that equal sign? You just bring it down. So ladies and gentlemen, we call this the elimination method because we eliminate a variable by modifying one equation or both equations. Now we have a simple equation that we could solve. We have a negative 17y equals 34. What do I do to solve that?
You divide by negative.
Divide by negative 17. Divide by negative 17. And your answer is y equals negative 2. Cool? And once again, that's only one answer. You need both answers. So if I have one answer and I need the other answer, what do? Plug it in. So which one do you want to plug it into, the top one or the bottom one? Top one? I'd probably go with bottom. You know what, at this point, whatever. Yeah, the bottom one is a little easier. Because if I wanted to solve for x, if I take the -2 and plug it into y, then yeah, I would just get an answer, subtract it over, and I have x by itself. So let's plug in this -2 into the y right here, okay? So I'm going to plug a -2 in for y. That's going to be x plus 5 times -2 equals -9. So we really have x minus 10 equals -9, which means when you add 10 to both sides, you get x equals 1. So your answer is, that cancels, x equals 1. So those are your two answers, x equals 1 and y equals -2. So if you wanted to write that as a coordinate, go for it, 1, -2. So we solved this thing. This one, if I would have set up both of them in slope-intercept form and graphed them, where would they intersect? At the coordinate 1, -2. That's your answer, silly. That's right, 1, -2. That's where they would intersect because that's our answer. So it's really up to you guys whether you want to use the above method substitution or the below method linear combination. Now, I'll tell you this. The only time I would choose substitution, and it doesn't even happen that often, is if you already have a variable by itself on one side. So for example, if this guy, let's say they didn't give me this. Let's say they gave me this instead. X equals -3y plus 3. So let's pretend that this is really this one right here. And this was the system. Then, yeah, I would use substitution. Why? Because, well, it already has x by itself. So I'm just going to take this one and plug it into the x, right? And then I could get my new equation and solve. But I really rarely use substitution at all. Usually, it's linear combinations. Now, this top one right here, we could have done linear combinations by modifying. If you could still see the original, I scribbled all over it. I apologize. But right here we have a 2x. Right here we have an x. I would multiply this bottom equation by -2. That way you could get the x's to cancel. That way you could solve with linear combinations. So down here, we have more practice. I would like you guys to practice. But before we practice, let's read this note right here on special cases. Pretty much it says that if you're ever working on a system using the elimination method, or even substitution for that matter, and everything eliminates, and you end up with something true, like 0 equals 0, everything eliminates, then you would say infinitely many solutions. But if you're working on an equation or on a system using linear combinations, and something impossible happens, like 0 equals 5, then you would say no solution. That would mean that they're parallel, okay? That they would be inconsistent if we wanted to use the appropriate vocabulary. So anyway, let's try one of these. Which one do you think is easier to cancel, x's or y's? Yes. Now, why is that in this case? Because you could easily cancel out y's by changing this to a what? To a +9. It's already positive, so all I have to do is do what to that top equation? Multiply it by 3, right? Because it's already positive, so if you multiply it by 3, it becomes 9, and that would cancel out with this -9 when we combine the lines, okay? Now, if I wanted to cancel out x's, what would this x have to be? If I wanted to cancel out x's, just for fun. This would have to be 15, and this would have to be what? -15, right? So the top one you have to multiply by 5. This one you have to multiply by -3. That way you could get a +15 and a -15 that would cancel out. But it's easier, obviously, to cancel out y's in this case by multiplying by what? 3. Okay, so let me rewrite this whole thing. And since I don't have much space over here to the side, I want to be going down here at the bottom. My top equation will be 9x plus 9y equals -45. And the bottom equation, we're going to leave it exactly the way it is. 5x minus 9y equals 3. And now I'm ready to combine the lines. 9 plus 5 is 14x. These guys totally cancel. Bring down the equal sign. Negative 45 plus 3, negative 42. So now, ladies and gentlemen, we have this simple equation in blue. 14x equals negative 42. What do I do from here? Divide by 14. Divide by 14. And yes, we will get x equals negative 3. Because a negative divided by a positive is a negative. Now we have one answer. All we need is the other answer. What do? Plug it in, right? So we're going to take this value of 3 and we're going to plug it in. Which one do you want? Top one or bottom one? Bottom? I would go with top. Okay, let's go with bottom. And into the x or into the y? Into the x, of course. Okay, so we're going to plug it right in there. And it's going to read, let me scroll this down and plug it and rewrite it down here. 5 parentheses minus 9y equals 3. So what goes inside those parentheses? The negative 3. And let's actually work it out now and solve for y. So this is going to be a negative 15 minus 9y equals 3 plus 15 to get rid of the minus 15 plus 15. We're going to have negative 9y equals 18, which means that y equals what? Y equals negative 2. So there is our solution for number 1. You could put it in coordinate format if you'd like. The x value is negative 3. The y value is negative 2. That's your solution. If they asked you to classify it, which I won't on all of them, but if I asked you to classify it, you would say it's consistent independent. If you were to graph it, it would only intersect at one point, and that point would be negative 3, negative 2. What do you guys think? Now let's take a look at number 2 here. Which one do you want to cancel, x's or y's? X's? Let's go with x's. The numbers are a little smaller. Let's go with x's. How could I cancel out the x's? Multiplying by the bottom one by what?
3.
By 3. So the top one's going to stay the same. Let me rewrite it. And the bottom one's going to change. Let me distribute that 3 in there. So we end up with negative 6x minus 15y equals 27. And now we're ready to combine. And we wanted the x's to cancel. That's beautiful. But look at what happens to the y's. They also cancel. So what do you end up with on the left side of this thing? 0. The equal sign comes down. Is negative 12 plus 27 0? No, it's 15. And it doesn't really matter at this point. 0 cannot equal a number. So right here we could just stop and say what?
No solution.
No solution. You could just put this symbol right there on your answer spot. Now I kind of am running out of time on this video, so keep in mind, if you would have ended, if like these guys would have canceled, and like let's say this would have been a 12 down here, it would have also canceled, then he would have had 0 equals 0, then it wouldn't have been no solution, it would have been infinitely many solutions. Okay?